In this video, we're going to take a look at a slightly harder sine rule question that involves composite triangles. So basically two triangles put together, like this one here. There's two triangles there. In fact, there's three. There's a big one as well, but there's two main shapes going on. We have a right angle triangle here in green, and the purple triangle is a non-right angle triangle. So as soon as we see something like this, we know that it's going to be a little bit trickier than the triangles shown in the previous video on the sine rule that involved just one triangle. So because it's a little bit trickier, there's a couple of extra steps highlighted here in green and orange. The first step is, and I mentioned in the previous video as well, it's handy to, if you can, find any missing angles using the 180-degree rule. So we know that three angles in a triangle add up to 180. So if we look at the purple triangle, we've got 23 degrees here and 30 degrees here. So we've got two angles. So we should be able to find this one really straightforward by adding the two that we have together. That gives us 53. And then minusing that from 180 to see what we're left with. That leaves 127. So we know now that that angle there is 127 degrees. So what else can we do? We can also use the 180-degree rule in a different way, in the way that there's two ways you can use the 180-degree rule. The first one we already did, and that is that the three angles in a triangle, A, B, and C, will always add up to 180 degrees. We just used it there to find 127. The second way you can use the 180-degree rule is to remember that a straight line angle is 180 degrees. And if you notice down along the bottom of this shape, there's a straight line. And the entire angle that makes is 180 degrees. Now that should help us find this angle in here. Because if we know that 127 degrees are already marked in here, well then the remainder, the bit that goes in here, will be whatever's left over from 180 take away 127, which of course we know is 53. So we know then that this angle here is 53 degrees, because together you've got your 180. So now we can also find this angle up here using the 180-degree rule. Three angles in a triangle add up to 180. Because this is 90. That's what that shape means down there. It's 90 degrees. And if this is 53, well, we can add those together. 90 plus 53 is 143. And take that away from 180. You're left with 37. So now we know what this angle is. It's 37 degrees. So now we've got every single angle in the shape. We now know what it is. First, we use the 180-degree rule on the purple triangle to find that missing angle. Then we used the straight line 180-degree rule to find that missing bottom angle of 53 degrees. And then we went back again and used the 180-degree rule to find that missing angle in the green triangle up there, 37. So when all of that is done, when all of that green step there is done, you can now break up the shape into two triangles. And it's much easier to work with two separate triangles rather than trying to figure out one big one. So we've got the green triangle and we have the purple triangle. So I just separate them. Okay, it's much easier to work with them when they're separated. Just use a black pen there on that one. Now fill in the angles that we've just discovered. Okay, so we've got, what have we got? We've got a 90-degree angle there. We have 37 degrees up here. We have 53 degrees down there. We have 127 here. We have 23 here. And we have 30 degrees down here. Okay, now let's look at the, also we know that this side down here is 15. That's given to us in the question. Right, so let's look at the actual question and see what we've been asked to find. So, in the question, it says, find AC, okay, A to C, which is from here to here. That's C down there, so this line there. That line there, which corresponds to either this side in the green triangle or this side in the purple triangle. They're both the same because they're shared. They share that side. So that's where we're going to start. We're going to start by finding AC. How do we do it? Well, first of all, let's look at the two triangles that we have here. And which one do we know more about? That's where you always start. You always start with the triangle that you know more about. And in the green triangle, I have been given three angles. 37, 53, and 90. So I have three angles. So it's a good bit of information, so I'm happy with that. In the purple triangle, I've been given 1, 2, 3 angles, okay, but I also have been given one side, the 15. So this is the angle, this is the triangle I'm going to start with. I'm going to use this purple triangle to begin with. I'm going to use the trigonometry rules on this one. Maybe it's the sine rule, maybe it's the cosine rule, maybe it's whatever. Of course, for the purposes of this video, it is the sine rule. Okay, that's what we're looking at here, the sine rule. But always start with the triangle that you have more information on. And that, in this case, is the purple triangle. So, we're going to use that purple triangle to find that side, AC, there. So let's look at the rules, or the steps to use the sine rule. These are the steps to use the sine rule here. We looked at them in the previous video. We had to do 2 extra ones for this because it's a joined up shape. The first one, label the angles big A, big B, big C. And it doesn't matter which one is which for angles. So I'm going to call this one A, this one B, and this one C. Okay, that's my first step. What comes after that? Label the opposite sides. Small a, small b, and small c. Okay, so what that means is if this is big A, well then the opposite side to it is small a. If this is big B, well then the opposite side to it is small b. And if this is big C, well then the opposite side to that is small c. So that's step 2. Step 3, write down the sine rule. So the sine rule, remember, it's in the logbook. It's small a over the sine of big A is equal to small b over the sine of big B is equal to small c over the sine of big C. So I've written down the sine rule. Now fill in the information that you have. So A, Do I have A? Do I have small a? Yes, I do. It's 15 over the sine of big A. Do I have big A? Yes, I do. It's 23 is equal to B over the sine of big B, which is 127, is equal to C. Don't have C, over the sine of 30. Okay, we've done step 4. Now step 5. Pick 2 of the fractions to use. Now remember from the previous video I explained which 2 to pick. You must pick the fraction that contains the bit you're looking for. Now remember, in the question we've been asked to find AC, which is this side here, this green side here, which is basically C. So I must use this fraction. And then pick the other fraction that you pick should be the one that contains everything you know. So there's no point using that one because I don't know what small b is. So I'm going to use this one. Okay, so those are the 2 I'm going to use. 15 over the sine of 23 is equal to C over the sine of 30. And then I cross multiply. So up and up. So it'll be 15 by the sine of 30 is equal to C by the sine of 23. You can call C x as well if that helps. I want to get C on its own, so I need to move this to the other side. At the minute, it's multiplying by C. So if I move it to the other side, it will divide. And I'll type that into my calculator, and that will give me what C is. I will then have what C is, which of course we know is the same as this side on the blue triangle. So whatever you get there, you now put it there because it's the shared side. And that should help you do the second part of the question, which is, let's see, it is to find AB. And AB is this side here. So we're working with the green triangle now. And we're asked to find this side here, AB. Well, notice for one thing, this is not a sine rule question. It's not a sine rule question because it's a right angle triangle. It's a right angle triangle. So it's going to be SOHCAHTOA, sine cos tan. Okay? So if we were to pick this, if we were to pick this angle down here to use as a reference angle, over here would be the opposite. This is the hypotenuse because it's across from the right angle, and this is the adjacent. And we need to pick 2 sides. One of the sides should be the side that we have. Now we already have this because we found it in the previous question. And the other side should be the one that we're looking for, and we're looking for O. So we need to use the trigonometric ratio, either SOHCAHTOA, that has H and O in it. And of course, that would be that one. So we would use that to find that side. The sine of 53 is equal to opposite over hypotenuse. We will know what hypotenuse is. We found it in the previous question. So we're just going to bring that over to the other side. Whatever you got for it in the previous question, put it in there. Type that into the calculator and you'll have what O is. And that's all sides of that shape found.